In today's video, we're going to discuss properties of functions. Specifically, we're going to discuss whether a function is even or odd, or possibly neither, and also if it's increasing, decreasing, or possibly constant. We're also going to revisit the topics of whether what the domain and range is of a function, and finally the intercepts of a function. We're going to start with an even function, and we're going to define it as using ordered pairs to start with. So if the ordered pair x comma y is on the graph, then the ordered pair the opposite of x comma y is also on the graph. Okay, so again, if you have an ordered pair x comma y, then the opposite of x comma y must also be on the graph. Another way to represent this or say this is if you have the function f of x, but you input the value opposite of x, then you will continue to get the same output of f of x. Now that's function notation, so again, just to translate that into something you're more familiar with, if you were to take the value x and substitute it in for f of x, you'll get out a value y for your output, right? Or f of x is also your output in function notation. If you were to put the opposite of x into the function, you'll get the same exact value. So again, it's saying exactly what we just said with the ordered pairs, but with function notation. Lastly, I'm going to represent this or say this in a different way, and we'll say the graph is symmetric with respect to the y-axis. Okay, so again, if a function is even, it will be symmetric with respect to the y-axis. This brings us to an odd function, and an odd function, I'm going to use a lot of the similar language, but again, it's not going to be exactly the same, otherwise it wouldn't be different. But an odd function, if the ordered pair x comma y is on the graph, then the opposite of x comma opposite of y is also on the graph. Likewise, using function notation, what this means is that when you substitute the opposite of x into your function, you will get the opposite of f of x. In other words, quickly saying that if you substitute the opposite of x into your function, you'll get the opposite of y as your output compared to if you were to substitute x in there. All right, that's function notation. Again, one more time, the graph is symmetric with respect to the origin. In this set of examples here, we have three functions, and we're going to determine whether each is even, odd, or neither. And basically, we're going to look to see if they satisfy the definitions we already discussed. If they don't satisfy either of those definitions, then they would be considered neither. To do this, we could graph these and test for symmetry. That's one way to do it. To do it algebraically, however, we are going to substitute the opposite of x into our function to see, after we simplify, what will we get. If we simplify this and get the same function, meaning 4x cubed, as a result, then we know it is even. If we simplify and we get the opposite, so in other words, negative 4x cubed as a result, then we know it's odd. And if we get something else, then we know it's neither. All right, so let's go ahead and simplify this. So f of opposite of x is equal to, now remember, negative x cubed is negative x times negative x times negative x, which is negative x to the third. So this is 4 times negative x to the third. So that will equal negative 4x cubed, which is the exact opposite of f of x. which means that this function is odd. Okay, going to our second problem here. Same exact process, so f of negative x is equal to 2 times negative x to the fourth minus negative x squared. Okay, so negative x to the fourth, that's simply taking negative x times negative x times negative x times negative x. And really, the focus has to be on the negative. So negative times a negative times a negative times a negative. Does that equal positive or a negative? And in this case, it actually is a positive. So same thing, negative x to the second, a negative times a negative is a positive, so this will just be simply x squared. So is this the same, exactly opposite, or is it something completely different? Well, this happens to be the exact same as f of x, what we were given, which is 2x to the fourth minus x squared, so therefore this is even. Finally, we have h of x, which is h of negative x is equal to 3 times negative x to the third minus 5. So again, we continue to simplify, and we saw with the previous example, problem number 1, that negative x to the third is just simply turns into negative 3x to the third minus 5. So notice here that the negative 3x to the third term is opposite, but the negative 5 remain the same. So in other words, this is neither f of x or the opposite of x, so this is neither. Now we're going to discuss whether a function is increasing, decreasing, or constant. And to do this, I set up the beginning of our definition. It says a function f on the open interval I with x sub 1 being less than x sub 2 is, and there are 3 different situations. So the first one would be, that I'm going to define, is increasing. So it is increasing if f of x sub 1 is less than f of x sub 2. All right, what this simply means, and I'm going to go to the graph on the right here, is that as we read the graph from left to right, if the outputs for those x values are increasing, then our function is increasing. So in other words, just giving you a function here, if our graph is increasing as we go from left to right, then our function is increasing. The second possibility is decreasing. So for decreasing, this happens or occurs when or if f of x sub 1 is actually greater than f of x sub 2. So in other words, as you move from left to right, reading your function or your graph, if the outputs are decreasing, then the y values are decreasing, then your function is decreasing. So look at the blue section of our function off to the right. And finally, we have the possibility that it is constant. So it is constant if f of x sub 1 is equal to f of x sub 2. So in other words, as you read the graph from left to right, then you know it's constant if the y values are not changing. So in other words, it's plateaued. So I've given you a visual for each circumstance. So it's increasing if you read the graph from left to right, it's increasing output. It's decreasing if it's decreasing output, and constant if it remains the same. Now to test this with functions, you could pick 2 values for x, let's say 0 and 5. And if the outputs for 0 and 5 were increasing, then it's an increasing function. Decreasing, that's a decreasing function. If it's the same, then it must be constant. Our last problem is asking us to use the graph to the right, problem number 4, to find these 4 different things. A, which would be the intercepts, B, the domain and range, C, the intervals for which it's increasing, decreasing, or constant, and then D, finally, whether it's even or odd or neither. So let's start with A, and we didn't really discuss this in the video, but it was in a prior video or in class. A, it is the intercepts will be anywhere it intersects or even touches the x or y axis. In this case, it intersects the y axis here, and the x-axis here and here. So therefore, the intercepts would be 0, 3, 2, 0, and negative 2, 0. All right. B, finding the domain and range. So again, domain are all allowable inputs. Well, the lowest possible input is at -4, and the largest possible input is at +4. You notice that it does not go below -4, and it does not continue to go beyond +4. So my interval, and I'm writing this in interval notation, this is for domain, by the way, my interval would be -4 to 4 using brackets. Range, I'm going to do the same exact idea here. Let me erase some of my work. Except in this case, I'm looking for possible outputs. So what is the largest output that is presented on this graph? Well, that would be +3. And what's the lowest possible output? That would be at 0, two different cases. So our range would actually be from 0 to 3, and it does include 0 and 3. And again, that's in interval notation. So we need to find out whether the graph is increasing or decreasing or constant, and for which intervals it happens to be doing that. So I'm going to write increasing, decreasing, and I'm actually not going to write constant because I can tell visually very quickly that the graph is not constant at all. So I don't think we have any constant intervals. All right, so we're going to start on the left-hand side, and we're going to go to the very leftmost point, and we're going to increase to the next point. So as my x's increase, what's happening with my y values? Well, as my x's increase, my y values happen to decrease up until -2. So we have a decreasing interval. So it's from -4 to -2, and it's decreasing. Now notice here I put parentheses around that. Again, this is interval notation because at -4 it's neither increasing or decreasing. At -2 it's neither increasing or decreasing. You could call those inflection points. They're points at which the graph actually changes from increasing to decreasing and is considered neither increasing, decreasing, or even constant. All right, so we continue with the graph, and we're looking at the next section of the graph, which I'll represent here in blue. So we continue from -2 on to 0. So this section of the graph, what's happening? Well, as the x's increase, the y values happen to also increase, so this would be an increasing section or interval. So we go from -2 to 0. Again, it cannot be equal to -2, meaning it's neither increasing or decreasing on -2 or on 0. All right, let's continue. And from 0 to +2, it's also decreasing again. So this would be another decreasing interval. So 0 to +2. Notice here we're referencing always the x values. Again, x values would be our intervals. We're not really looking, we're listing our y values. And then finally, the last interval happens to be from +2 to +4. So we happen to be increasing again. So that'll be from 2 to 4, not equal to 2 or 4. And again, I'm referencing the x values. So those would be the intervals that I'm increasing and the intervals that I happen to be decreasing. Finally, we're determining whether this is even or odd or neither. And again, going back to our definitions of even or odd or neither, you can determine this by looking at the outputs. You could also determine this by looking at the symmetry of the graph. So looking at the outputs, you can tell that for the input -4, you have an output of 2, and for +4, you have an output of 2. You can tell by an input of -2, you have an output of 0, and for +2, you have an output for 0. So that actually matches one of our definitions. Also, you can look and see that this is clearly symmetric with respect to the y-axis. So either one of those things should tell you that this is actually even.
You're a singer. You sticker.